Hello and welcome to the final presentation for the REDMANE Web Development Team Summer 2025-2026. It's been a very interesting intake across all the REDMANE teams, and in particular with the REDMANE Web Development, we were looking at a few different options as well. But I won't give away any secrets. I'll hand over to Nash to take you through it. Thank you, Nash.
Thank you, Roland. So, hi everyone. Welcome to the REDMANE Web Development Summer 2026 presentation. So, just an acknowledgement of country, we would like to start by acknowledging the traditional owners of this land, the Wurundjeri and Boonwurrung people of the Kulin Nation, and pay our respects to the elders past and present, and also future. That should be on the slide. Meeting structure. So we're going to just start off by the high level stuff. We'll start introducing our problem statement, what REDMANE is, and then continue on with our demos and individual contributions throughout the internship. So just a team introduction. Hi, I'm Nash. I'm in my final semester of Bachelor of Science in Computing and Software Systems at UNIMEL. You go.
Hi everyone, I'm Soham Das. I'm a second year, second sem at the University of Melbourne. I'm studying computing and software systems.
Yes.
Hello everyone, I'm Yashashri and I'm final semester Bachelor's of Science student of Computer Science from University of Delhi, India.
And
there's my teammate Yi, and she is doing Masters of Engineering from Melbourne Uni.
And Manya is she was also an intern at this intake as well, and she's also currently studying in her final semester of Bachelor of Science in Computing.
Hi everyone, my name is Yingjing. I'm studying Bachelor of Science, majoring in Computing and Software System in UNIMEL.
Cool. So, Yashasvi, I'll hand it over to you.
So our main problem statement is research data without a library. So modern research data is highly distributed across labs, servers, and institutions with no unified catalog. Raw, processed, and summarized data are often disconnected, making traceability very difficult. Secure collaborations across organizations becomes complex due to privacy, infrastructure, and governance constraints. As a result, researchers spend significant time locating and validating datasets instead of analyzing them. This is a very big wastage of time and our resources. So the main idea of REDMANE was as a digital library for research data. REDMANE addresses this by acting as a metadata-driven digital library for research data. The data registry does not store raw genomic data. Instead, it stores structured metadata that points to where data resides. This allows controlled, role-based access while maintaining data privacy within institutional boundaries. Researchers across organizations can reference and analyze the same datasets without duplicating sensitive data. In short, REDMANE enables secure, fair, and collaborative data usage during active research. We can find data in minutes and not in days or hours.
Yeah, to explain what the REDMANE actually does, let's use a library analogy because at its core, a data registry works a lot like a traditional library just for research data. Think of REDMANE as the library itself. Instead of books, we have genomic files like FASTQ and VCF files. Instead of a library catalog, we have the REDMANE database that tracks everything. And just like the Dewey Decimal System organizes books by category, REDMANE organizes data in a hierarchy from organizations down to project, then patient, and then dataset. When you walk into a library, you use a library card to borrow books. In REDMANE, that's your JWT token. Your digital identity proves who you are. Your borrowing privileges, whether you can read, write, or administer, map to the role-based permissions, viewer, researcher, or admin. Just like a library can have multiple branches, REDMANE supports multiple organizations like VHI, UNIMEL, and RMH. Every time someone accesses data that's recorded in an audit trail, like a checkout log. Admins are librarians keeping everything running. And instead of shelf location, data has file path. Finally, just like you research a card catalog by subject or author, the admin actually lets you search by metadata like patient ID, tissue type, or date. Now let's look at how admin is actually structured at a high level. At the center, you have the data registry, and importantly, this stores metadata only. It doesn't hold the actual raw data files. Instead, it points to where the data lives across different organizations. So organization 1 might be WeHi, organization 2 might be another institution, each holding their own raw process summarized data. The registry acts like a connective tissue between them. On the right side, you can see what we call an app store, a collection of visualization tools like Omero, Redcap, Aquila, and CBioPortal. These applications connect to the registry and allow end users, particularly non-computational researchers, to explore summarized data through familiar interfaces without needing to touch the raw files directly. So in short, the registry points to the data and the apps, and the data and apps point back to the registry. It's a two-way ecosystem. This slide covers three features of REDMANE. First,
I don't think we
okay,
can hear you,
this,
Soham. Oh,
sorry,
now we can.
sorry, okay, yeah. Okay, this diagram zooms out to the full data commons, everything working together as one system. At the center of the data registry, running inside Docker containers, inside it, you have got a React.js frontend, a fast API backend, and a PostgreSQL database storing all the metadata. Below the registry, you can see two storage environments. Sorry, Nash, can you go back?
Yeah.
Slide.
This one?
Yeah. Okay, finally, let's look at what happens inside the data registry itself when a user interacts with it. A user interacts with the React.js frontend. This could be researching in a dataset, viewing metadata, or submitting a request. The action triggers an API call to the fast API backend. The faster then queries the PostgreSQL database, which is where all the metadata is stored. When the results come back, FastAPI returns them in an API response, and the frontend updates to display the new information to the user. The whole thing runs inside Docker, which handles containerization and deployment. Only can be consistently run across different environments without compatibility issues. So it's a clean, modern three-tier architecture, front-end, API layer, and database, all containerized for reliability and portability. Here are the GitHub repos the team has worked on, and you can find more information on. Thank you.
Cool. So our goals as a group were so there's like I guess three big features. So me and Soham worked on the authentication on the data registry, specifically using OIDC to implement that. Yashasvi and Yi worked on linking data sets from the data registry to data portals, and Yingying worked on a downloadable README file to the dataset folder. So as you can see, the highlighted yellow parts are essentially where we ended up completing it. I think a lot of we were in stage 2 or 3 for a while, at least for the authentication part, but we finally got it to be completed. Now we'll go to Soham's demo.
Hello everyone.
Let me just increase the volume. Can everybody hear the video?
Today I'm going to show you how Auth0 handles organization-based authentication in the real web application. We have users from different organizations, and each user should only access data from their own organization. Let's see how Auth0 makes this secure. Okay, so we begin with index.js, where we actually configure all the environment connections and connect our web app to the Auth0 client. The redirect URI where the auth 0 sends users after login. And the most important parameter here is actually audience. This tells auth 0 that we need an access token for a backend API. This is very important because the token will include organization information. And we wrap our entire web app to the auth 0 provider, which will handle all the auth 0 and OIDC flows automatically. Now let's move on to the home.js. So this is the main button here. When the user clicks login with auth 0, we call auth sign in redirect. This does something pretty cool. It actually redirects the user to the auth 0's login page. Now let's move on to the home.js. Now, since the auth 0 redirects back, the auth 0 automatically stores the tokens and sets auth dot is authenticated to true. We then navigate to the data page. Now, coming on to the actual data, here is where we use the token that we receive from auth 0. So the main part here is this token here. This is the JWT token that auth 0 has given us. Not just a random string, it's actually a cryptographically signed token that contains the user's organization ID. We then attach this to every API request in the auth 0 header as the bearer token. This token is the key to everything and accessing all the endpoints in our application. Okay, now let's move on to the backend, which is starting off at auth.py. So this is where the real security actually happens. It's when our backend receives a request with a token, and we need to verify if the token is legitimate. So this class is the verify token class. We configure the verify with auth 0 settings. Let's look at the actual verification process. So first, we fetch the JSON Web Token key set from auth 0. These are auth 0's public keys. Think of it like auth 0 signed the token with a private key, and then we use a public key to actually verify if the token is authentic. Now we actually validate the issuer and the API audience. We decode the JSON Web Token using the public key. We are verifying things such as audience, which matches our API. So the token was meant for us. And the issuer is actually our auth 0 tenant. So it came from the right place. It's verifying that it came from the right place. And since these two are valid, the token hasn't been tampered with, and we can access our API endpoints accordingly. If any of these checks actually fail, we reject the request. But if it passes, we get back the payload. And inside the payload is the user's organization ID. Now, coming on to actually extracting the organization ID, we use this function here. Once we have verified the payload, extracting the actual organization ID is very simple. Auth0 automatically includes this as org ID in the token. Now, onto the actual finale. This is where the actual enforcement of organization-based access control works. Let's look at the endpoint that actually specifies the data by the ID from the token. If we go to main.py, get here, this, as you can see, the last parameter here, this is the dependency payload, which is a fast API dependency injection. Before this function even runs, fast API will automatically call the token verification. And if the token is invalid, the request is rejected here. And the username actually gets past that point and runs this function. If the token is actually valid, we extract the user's organization ID from their verified token. And if there is no organization ID, they are forbidden and the access to the endpoint is denied. Now, to actually get the data, we use this part of the code. We look up the requested data in the database. Here is the part where we check if we have a user that actually belongs to the organization for the data that we are extracting. We compare the data's organization ID with the user's organization ID from their token. And if they don't match, we return a 403 forbidden. And the user can see the data exists in the list, but they can't access the content unless they're in the right organization. And if the IDs match, we can return the data and access to the data has been granted. If we get a 403 response, we show a clear message that they don't have access to this organization data. But if the user is in the right organization, we return this piece of the code. It is a nice green banner that actually displays authorized access granted and will display all the data. That's it for the authentication flow to extract data according to the user's tokens. Thank you. Hello everyone. Today I will showing you the demo for my web app, which handles authentication through various organizations via Auth0. First, we log in via Auth0 and this button and redirect us to another page that is handled by the Auth0 client. Currently, inside my Auth0 client, I have two organizations. One is organization A and organization B. I'll be using organization A for this demo. As you can see, I'm already logged in. Test.org A has 3 members, which includes me. Okay, here we go. This is the dashboard. Since I'm in organization A, I will be able to access data in organization A. And since I'm not part of organization B, this will be denied. As you can see, the alert has popped up. It is unauthorized access. And since I'm not part of this organization, I cannot use or access the contents of this file. Thank you.
Coolio. Now I will go on to my demo. Roland has convinced me to run a live demo, so hopefully everything goes okay. So what I will do is I've added a lot of configurations in the Keycloak for this to basically log me in because I had issues with that before. Okay, dev, coolio. Let me just make my screen bigger. So I'm gonna wait a little bit because sometimes this button doesn't work because I just composed up Docker. So right now it's not working. I need to like wait a little bit. There we go. I've configured that, and obviously my password is a dummy password, so I'm gonna get a Google alert. But as you can see, everything works pretty well. Everything works basically the same. But a way that we can actually test if if authentication is working or not is to log out and then go to the Fast API localhost and see if we can access it there. So we are trying to see if we can access the projects page without logging in. And as you can see, it's working the way that we want to, which is not authenticated. So when I didn't add the token handling in the Fast API routes Python file, I would usually get a big chunk of the projects page right here. So that's not something that we want. We want it to, we only see it in the login and only when we're logged in. And yeah, that's my demo. And I've also made an app as well. Oh, it's annoying, but I've also made an app as well. So you can check it out over here. And yeah, moving. Oh, and so what's actually happening here is, for example, I guess you can see in the upper half, that's what happens when you're not signed in. So it either says token expired or token just denied, and it goes back to the React page, or it goes back something else, or maybe the Keycloak page in this case. And when it starts from the React page, let's say that we do have the tokens to get in. Request resource with tokens, and then it goes to the fast API server, and then goes return to React, and then the user can display data. This is just an architecture diagram of the client credentials for Keycloak. So in this case, tokens are JWT tokens, like Soham mentioned before. Yeah, moving on to Yashasvi and Yi's demo.
In this demo, I'm showing the integration between the data registry and CBio portal using the metadata given approach. For each dataset, portal URLs such as URL CBio portal are stored in the database already.
Sorry, should
If
I
you can
play?
start the video.
Okay.
Yeah. Here I am running the backend and the front end before in the program, the basic code lines. So the backend and the front end are working properly. So when a user opens a dataset page, the frontend calls a backend endpoint to retrieve these external links. The backend fetches the metadata, validates that the URLs are HTTPS only, and returns them to the client. The UI then dynamically renders the data portal buttons. When the CBio portal button is clicked, it currently redirects to the CBio portal main page. This is because the dataset specific portal page has not yet been drafted. Once the dataset specific endpoint or portal routing is defined, the metadata can simply be updated to point directly to that page without changing the front-end code. At that stage, the button will connect directly to the dataset's analysis, viewing CBio portal, and allows seamless navigation back. So what this demo validates is that the integration mechanism itself, metadata-driven linking, secure backend validation, and dynamic UI rendering. And this is the diagram architecture I have made to explain it clearly what I have done. So architecturally, the flow begins at the React front end, which requests portal links from our fast API endpoint. Then the backend queries PostgreSQL for metadata fields, such as URLC bioportal. The API validates that URLs comply with HTTPS only rules and returns a structured JSON response. The frontend dynamically renders portal buttons based on these responses. There are no hard-coded links in the UI. And when clicked, the browser redirects to the external portal, maintaining a clear separation between the registry services and the visualization services. So the new
sorry.
No worries. So this metadata-driven architecture makes the system extensible. New portals can be integrated simply by adding metadata entries without modifying the front-end logic. That's it.
Yeah, thank you for that. So for individual contributions, for my contribution, I basically made essentially like around 6 repositories, all basically like one for each my app and the data registry. It was Auth0, OI, DC, and then Keycloak. That was so much harder than I thought, and it took understanding how everything fits together at a high level to really get down to be comfortable with like the high level architecture, and then that by understanding a lot of that speeds up technical execution. And I think in this internship I learned more to ask for help if something is taking too long, or ask a supervisor or teammate for help if anything takes too long. Cool.
Okay, so my main focus was on understanding and implementing the authentication layer that underpins a system like REDMANE. And to do that, I built a web app from scratch, specifically to explore how JWT-based authentication works in practice. Within the app, I implemented Auth0 with organization-based access control, meaning different users see different content depending on which organization they belong to. The stack I used mirrors admin's own architecture. So there's React on the front end, Fast API on the back end, and Postgres as the actual database. And it all tied together with JWT authentication. And I also built an organization ID verification and boundary enforcement, which ensures users can only access data within their permitted organization, and they can't cross into another organization's data, even if they're authenticated. And in terms of what I took away from all of this, three things would, I guess, stand out. First thing is that I got hands-on experience with Auth0's OIDC integration, especially how organizations' claims are embedded in JWT tokens and then validated server-side. And I also built a full stack authentication flow with protected routes. So now I understand how the front end and the back end need to work together to keep boundaries secure. And thirdly, I developed a solid understanding of authorization patterns for multi-tenant systems, which is the kind of organization and environment REDMANE operates in, where multiple organizations share one platform, but their data must remain completely isolated.
So my main task were to set up a local development environment, Postgres, by using Postgres, Fast API backend, React frontend, and find the shortest route and record all the possible issues that can be on the way and document it. I also integrated dynamic external data portal links using dataset metadata, created demo datasets and metadata entries, made the graphical architecture, learned how to create a graphical architecture of whatever the technical work I have done, ensuring HTTPS only validation for portal URLs and end-to-end demo flow verifications. I have learned so much from this internship. I learned how it's important to plan repository branch strategy before coding, how to be in link with my teammates and my supervisor, how to design metadata driven features without hard coding in the UI, debugging the backend DB database schema mismatches and API validation issues, and end-to-end integration across the database API and frontend. I learned how the value of clear team coordination are important, and early alignment on demo expectations is very much needed in the project, and how to build the demos that mirror production architecture using placeholder, and how to express what you are truly meaning to do. Thank you. So my teammate Yelu set it up the local development environment using the PostgreSQL Fast API backend and React frontend. She integrated dynamic external data portal links based on dataset metadata. She created the program for the demo datasets and corresponding metadata entries, implemented, wired, and tested backend API endpoints for retrieving external portal links. She wrote the API design documentation for internal review and the feedback. What she learned was the importance of timely and proactive communication to avoid misunderstanding and rework between the teammates and the supervisor, and how to check database schema. The importance of asking higher level strategic questions rather than focusing solely on implementation details. and how proper API documentation improves team collaboration and accelerates review cycles.
For Manya, she worked a lot on researching to deploy a data registry using Docker. So she set up a lot of SSH access to REDMANE data registry. Yeah, a lot to do with data registry, SSH, and VM. She verified the Postgres container state by checking by a lot of intricate details, and yeah, basically she helped containerize Postgres and reviewed the backend code to, have the repo that we have today. And what she learned was to ask small specific questions so she can help narrow down the real issue faster instead of guessing and doing extra work. Um, Regular checking with supervisor early and writing down what she's confirmed to keep her from getting lost and makes next step obvious and keep everyone in the loop.
For my contribution to the project, I started by forking and setting up the REDMANE React repository for our team so that we can all manage our work in one place. I follow a structured Git workflow by creating feature branches, pushing updates to those branches, and merging changes through pull requests. I also set up and ran the full application stack locally on my computer. This helped me to understand how the front end, back end, and the database interact within the system. For the feature itself, I developed a front-end based README file generation function. The README file is generated dynamically and contains an URL which links the user back to the corresponding dataset page. Moving on to what I learned, since this is a complex project, understanding the existing structure was an important step. I learned the importance of asking high-level questions early to gain a clearer understanding of the project itself. I also strengthened my understanding on full stack environment setup, such as setting up Postgres and also connect the backend to the front end. Lastly, I gained practical experience in Git workflow management, including feature branching and branch cleanup after merging. Next, please.
Yashasvi. Sorry.
Next, I would like to share a few tips for future interns. First, have multiple meetings when needed and communicate frequently with your teammates. In a project like this, regular communication really helps to avoid misunderstanding and to keep everyone aligned. Second, ask questions frequently and early, as it is always better to clarify things at the beginning. I would also recommend reading previous interns' documentation and slides, as they provide you with a strong head start in understanding the structure. Another useful approach is to create a small web app to simulate features before integrating them into REDMANE. Testing and even breaking things in a safe environment helps you to understand the system better. And also, remember to update your technical diary, as it helps your teammates to solve similar problems faster. And don't be afraid to ask unprepared questions, even if they seem too basic or too detailed, like how to run Postgres properly. This small clarification can save you lots of time. Finally, at the technical diagram level, strict notation doesn't always have to be perfect.
Yashasvi.
So the internship feedback and how the program can improve. So the pros are a lot of opportunities for touch points to ask questions, clarify understanding, show Roland what we have done. Getting to work on complex full stack project, which leads to many more new opportunities and helps us to understand how to handle complexity. The potential improvements that could be done is to have at least one in-person meeting with the team for bonding and better teamwork and camaraderie later in the internship program. Have one contact with a previous intern in the last intake, which the team can get in contact with to better understand the expectations, especially in the start of the internship stage, and make students read the newly made fast track reports at the start of the internship. Thank you.
Cool. So I'll end it here. Thank you so much to Roland, and thank you so much to everybody, Manya and Nandi. They're not here, but they're here in spirit. Thank you for the opportunity to do this project. And yeah, we'll open the floor to any questions.
Thank you very much. I just want to point out that this particular project for this particular intake, I think there was a lot of learning around how to collaborate. And I could see that as things progressed, you started to realize there were ways that you could actually collaborate better together. And you're starting to catch on at the end. So the fact that you got this far, really well done.